This is 16.2.1, again, front half of 16.2. This one's number 6, and it asks us to evaluate this integral. You can see this one's a little different from the previous one. Instead of integrating over a path, we're going to integrate it over two paths. We're going to integrate it first over the x path, then a different function over the y path. This is probably the result of a dot product of the x and y vector components of the function times the x and y vector components of the path. Now the path in this case is constant x, so that's a vertical line, and we're going to move from 0 to 4 along that vertical line. Just like the previous one, we just want to parameterize this. So our parameters are going to be that x is equal to 4 plus 0t. So that one isn't really parametric, it's a constant. But y is going to be equal to 4t plus 0. And then t will basically range from 0 to 1. Along 0 to 1, it'll map out from 0 to 4, and this one, of course, will stay constant. Just like before, let's take the derivatives of these so we can see how we're going to replace them in terms of t. So unfortunately, x is equal to 0 dt, so there won't be a front half integral, but y will be equal to 4 dt. Okay, now we should be able to make all the replacements. So I'm going to integrate from 0 to 1. Let's do the replacements separately just to make sure we get all the elements in. So first the x part. X is 4. E to the y, that's e to the 4t. And none of this matters because dx is 0 dt. And then I'll add to that again, this one's also 0 to 1. X squared y is going to be 16 times y, which is also 4t. And then another 4 for the 4 dt. Because the front half integral is 0, it's only the back half integral that will do. 0 to 1, this is going to be 256 t dt, and when we integrate that, we end up with 128. So similar to the previous one, it was already broken out with the dot product, and so we had to replace things separately instead of sort of doing it as one integral. It's done as two.